Conveyors are powerful machines that can carry hundreds or thousands of tons of material every hour. Key parts of a belt conveyor include the head pulley, tail pulley, bend or snub pulleys, and the counterweight pulley and counterweight. Other key parts are the loading idlers, troughing idlers, return idlers, and the belt itself. All of this equipment is supported on a strong steel framework. Belt conveyors present a myriad of hazards, and mere flesh and bone cannot stop their endless motion. Conveyor belts are loaded with material at the feed chute, just forward of the tail pulley, and material discharges at the head pulley, sometimes inside a housing or down a chute to a pile or another piece of equipment. Many belts are equipped with belt scrapers, usually located at or near the head pulley. They remove sticky materials and improve housekeeping under the belt. Spring-loaded scrapers or fixed rollers may extend across the width of a belt, creating a nip or pinch point. If these hazards are accessible during operation, they should be guarded. Some belt conveyors have small cleaning conveyors installed on the floor just behind the head pulley discharge chute. Short paddles rotate opposite to the direction of the main conveyor and sweep material that falls on the floor back into the discharge chute. These cleaning devices and their drive components should be guarded. Bend and counterweight pulleys are sometimes called take-ups. Their function is to automatically take slack out of the belt and to self-adjust when changes in temperature or load cause the belt to expand or contract. Counterweights are often used on incline belts and are usually placed in the upper half of the belt where higher elevations permit a counterweight to hang below it. The counterweight pulley holds a heavy weight and is hung between and below the two bend pulleys to tension the belt. Counterweight and bend pulleys have in-running nip points where the leading edge of the belting contacts the surface of the pulley. Nip points, pulleys, and shafts need guards to protect miners that can reach them from the ground, walkways, or stairs. The guard should prevent miners from reaching over, around, or through them to the nip point. Not all belt conveyors rely on bend and counterweight pulleys to tension the belt. In underground mines where headroom is limited, conveyors may use hydraulic cylinders or electric winches with highly tensioned cables to remove slack from a belt. In these cases, take-ups are positioned behind the head pulley and between the loaded and unloaded sides of the belt, and the belting is wound around them. Other belt conveyor systems have wheeled movable carriages to support the tail pulley shaft and its bearings. The wheels are mounted on rails or flat portions of the conveyor frame. Tension is applied by a remotely located counterweight attached to the tail pulley carriage by a wire rope cable and a series of sheaves or pulleys. Many mines guard the wheel rail pinch points and shield the tensioning cable to prevent it from injuring someone should the belt or cable break. Very short belts, like those on material feeders, are tensioned by fixed position threaded rod take-ups installed at their tail pulleys. Openings for adjustment tools should be covered, small enough and properly located to prevent contact with parts moving inside the guard. Cover the openings if your risk assessment indicates it is appropriate to do so. If elevated counterweights are used, they represent suspended load hazards. Areas beneath counterweights can be barricaded with cables, railings, or fences to keep miners from passing or working under them. Keep in mind that a well-designed barricade allows miners to remove material from under the counterweight without being exposed to the suspended load hazard. Idlers support the conveyor belting between the head and tail pulleys. These are loading idlers. They are mounted close together under the material feed chute and across the width of the frame. Pinch points exist between idlers and at the narrow gap between the feed chute and the belt, just above the loading idlers on both sides of the belt and at the rear of the feed chute. These areas should be guarded to keep body parts away. Troughing, or carrying idlers, may be long and straight, but are more likely to be combinations of 2 or 3 shorter idlers arranged in a V or U shape. Idlers so arranged fold up the edges of the belt to prevent spillage while supporting it underneath. They are mounted on top of the frame at more widely spaced intervals. In-running nip points exist wherever the leading edge of the belt passes over idler rolls. Hands or tools can be drawn in or through these nip points, possibly breaking bones or spraining joints. Best practice for these situations is to guard the idler nip points, but this is not required except where unguarded conveyors are located next to travelways. Covers, railings, bars, or screens can be used in metal and non-metal mines to keep miners walking beside or working on conveyors from becoming entangled in nip points between troughing idlers and the belt, or from falling onto the belt itself. Emergency stop cords can be used instead of railings at metal and non-metal mines, but they are required in surface coal mines. The cord should be positioned so that a miner entangled in the equipment can easily and quickly reach the cord, pull it, and stop electrical power to the motor. Where emergency stop cords are used, they should be in good condition, well secured, relatively taut, and free from knots or other obstructions that might impair their use. Return idlers are long and straight and are mounted across the bottom width of the conveyor's frame. They support the unloaded side of the belt after it passes the head pulley and travels back toward the tail pulley. Return idlers carry no load other than the belting itself. For this reason, they may be spaced at wider intervals than troughing idlers. Return idlers can be killers. They have the same in-running nip points found on head and tail pulleys and other idlers, and their relatively wide throat opening can pull in a hand at any point along the face of the idler. Where textured belting is used, or where idler surfaces are not smooth, the risk is higher that a miner might be drawn into the nip point. A number of miners have been fatally injured when their hand contacted a return idler nip point. While struggling to free themselves, both hands became caught, their arms were pulled in, and their head was forced up against the idler or the underside of the belt. The result? A broken neck. Return idlers that miners can easily contact should have their nip point guarded. Although multiple return idler nip points exist on any belt conveyor, the most dangerous ones are the ones 2 to 7 feet above the ground. In other words, be most attentive to those idlers that a miner can walk up to or under and reach from a normal work position. When performing your risk assessment, pay particular attention to inclined belt conveyors and those that pass over walkways. Many overlooked and unguarded return idlers have been found in these locations. There are several ways to effectively guard return idlers. Metal plates or angle iron can be used if set close enough to the belt but far enough away from the idler nip point. Rubber is not recommended because it is too flexible, nor is wood because it weathers poorly. Mesh or expanded metal boxes that completely enclose the idler can be used. Mesh openings should be large enough for fine materials to pass through, but small enough to exclude fingers, or the box should be larger for extra clearance. Hinge boxes are a good idea if material may build up inside, but the belt should be shut down and locked out before emptying them. Long mesh V's with open bottoms are another alternative, as are spaced bars or reinforcing rods. Some conveyors have turnover stations to permit wear on both sides of the belting. Notice how this fence restricts inadvertent entry to a large area and the moving equipment and pinch points behind it. Deliberate access could be prevented if the fencing were extended downward and a lock gate were installed. If there was a work-related reason for persons to enter the hazard area while the equipment was running, these improvements would decrease the risk of injury. Belt storage units consist of several closely spaced vertical layers of belting looped around a series of pulleys. They're used primarily in underground longwall mining operations where belt conveyors need to be alternately extended and contracted. Belt storage units are good applications for area guarding because they have numerous in-running pinch points close together where the belting winds over the rollers. Belt trippers are special unloading devices often used in storage halls to distribute material along the length of the building. They cause material to be discharged to the side of a belt rather than at the head pulley. Trippers add additional hazards to a conveyor system because they have their own pulleys, shafts, and motors. Many move along the length of the belt while it is operating and are self-propelled and remotely or automatically started. Those that ride on rails create moving wheel rail pinch points. Best practice is to provide belt trippers with alarms to warn of impending movement and to perform a risk analysis to determine what hazards need to be guarded and how best to protect miners at risk. Many operations decide to guard all moving parts for that extra margin of safety. Conveyor belting is not generally guarded even though it moves continuously. Keep in mind that belting, frames, and auxiliary equipment such as scales, samplers, and scrapers, like all parts of conveyor equipment in a mine, are portions of an overall system and interact with the other parts. So, look at the entire conveyor system when conducting a risk analysis. Good times to do this are whenever equipment at your mine is installed, modified, or repaired. Further modifications or guarding are in order if the risk assessment reveals that tolerable risk has not been achieved.